And we know there's a variety of nutrients where the nutrient status is associated with later dementia risk. Many of these you can see here. So folate and B12, omega-3s, vitamin D, zinc, iron, choline. These are some of the ones that we have some of the best evidence for in terms of long-term risk of dementia. So as an example, these are just data from a couple of meta-analyses. On the left-hand side here, we have vitamin D. We know that those who are deficient in vitamin D have a significantly increased risk of dementia. On the right-hand side, this is now anemia, so low levels of hemoglobin. This is often related to iron status, though could also be related to B vitamin status, or other aspects of chronic disease. But we know that those who have anemia have a significantly increased risk of dementia. We also know that these nutrient status factors interact and stack on top of each other. So there are now multiple studies that have looked at vitamin D and omega-3 and B vitamins and iron. And you see that as the number of deficiencies increases, you get synergistic increases in the risk of later dementia. Another example that I kind of mentioned briefly earlier is B vitamins and omega-3s. We know that low B12 in particular is associated with brain atrophy and dementia. This is often seen sort of in parallel with increases in the marker homocysteine, which is a measure of the requirements of B vitamins that relate to methylation status. So B12, folate, B6, and often riboflavin or B2 as well. And there are now several randomized controlled trials that show that brain atrophy and rate of cognitive decline are slowed with B vitamin supplementation. On the left-hand side, both of these graphs are taken from probably the first study to look at this. It was the VitaCog study that was run out of the University of Oxford by Professor David Smith. And here on the left-hand side, you can see all the different areas of the brain that were positively affected through B vitamin supplementation in individuals who had elevated homocysteine. So this was a homocysteine above 13. And these are areas where atrophy was slowed with B vitamin supplementation. So we're basically looking throughout the brain, but in particular, many of those same brain areas that I've talked about several times. But what's interesting is that they found there was an interaction between B vitamin status and omega-3 status, whereby the rate of change of brain atrophy was only decreased by B vitamin supplementation in those who had good omega-3 status. So if you had low omega-3 status, then B vitamins didn't seem to do much. And actually, there are now at least 2 other randomized controlled trials that have showed the same thing, the Omega-AD trial and the B-Proof trial. Both showed that there's an interaction between homocysteine and omega-3 status, and supplementing with one, if you have poor status of the other, doesn't result in any benefit. But if you have both, then you see significant benefits.